The selfish gene, in a nutshell. According to the selfish gene theory, Darwin's theory of evolution is best thought of not as a struggle for the survival of a species or even an individual, but as a struggle between genes. While genes are really just strings of chemicals capable of being copied and passed to offspring, the Oxford zoologist Richard Dawkins gave them the metaphorical property of selfishness. He then showed how their ruthless determination to be passed on could explain apparently senseless altruistic behavior whose origins puzzled even Darwin. Not all evolutionary experts accept this gene centered vision of evolution, and the metaphor of the selfish gene has led to much confusion and controversy. In particular, many people think that it implies that we are completely under the control of selfish genes, which undermine our morality and free will. However, as Dawkins himself has tried to make clear, modern humans are in the unique position of being able to rise above the selfish aims of our genes because we have a mind. It is our mind that allows us to transcend our physical limitations, and it also allows us to go beyond the cold Darwinian morality of genes. In 1976, a young Oxford University lecturer went public with a disturbing claim that the true nature of humans. About the true nature of humans. We are survival machines, he declared, robot vehicles blindly programmed to preserve the selfish molecules known as genes. This chilling statement appears in the preface to one of the most famous science books of the last 100 years, which propelled its author to international fame. He is Richard Dawkins, now a professor of Oxford and probably today's most influential advocate of Darwin's theory of evolution. The book in which he put forward his controversial claim is The Selfish Gene, whose snappy title led to huge sales and even bigger misconceptions. Many believe it is an account of Dawkins' discovery that all living creatures, including humans, are under the control of selfish genes that care only about their own survival and will do anything to show that evolution is best understood by thinking of genes and imagining them to be selfish. Dawkins does not claim that genes really are selfish or that they somehow know what they are doing. He doesn't claim to have discovered the evidence backing his vision of evolution. Least of all does he claim that we humans are powerless to resist the demands of our own selfish genes. Quite the contrary. Dawkins sought not only to bring this vision of evolution before a wide audience, and in so doing coined one of the most potent but potentially misleading metaphors in all science. The selfish gene is an idea that owes its origin to attempts to solve a mystery that had long puzzled evolutionists, including Darwin himself. In his most famous work, The Origin of Species, Darwin had shown how the struggle for existence acts as a feeler through which only some creatures pass, namely those best able to survive. They would then leave offspring which inherit those attributes, driving evolution onward. But Darwin knew that some creatures seemed to defy this ruthless logic. They had traits like bravery, which clearly reduced their chances of surviving long enough to have offspring. So, why did such traits persist? Why, for example, did birds give out warning cries to others despite the risk of being attacked themselves? Or bees indulge in suicidal stinging to defend their nests? In The Descent of Man, published in 1871, Darwin suggested that perhaps the process of evolution sometimes works not at the level of individuals but on whole groups. So, while bravery might not benefit the individual, it could benefit the whole group. As a mere 30 something researcher with no permanent post, Alain Aspect knew he was taking a career gamble by attempting to prove Einstein wrong. Hearing of this planned experiment, one leading scientist muttered darkly, "You must be a very courageous graduate student." Yet today, more than 20 years after he performed the experiment, Aspect is an academic celebrity. His name guaranteed a place in scientific history, for he studied in proving that intuition of the greatest physicist of modern times had for once been wrong. What Aspect and his colleagues found in 1982 went much further, however. They uncovered the first hard evidence for a phenomenon so rare that even today most scientists struggle to grasp its implications: quantum entanglement. As its name suggests, quantum entanglement binds subatomic particles together, but it does so in ways that simply boggle the mind. Perform an action of one particle and its entangled partners are affected instantly, no matter where they are or how far apart. It sounds like something out of science fiction, and it opens a prospect of distinctly futuristic applications, from ultraviolet computing or from ultra fast computing to Star Trek style teleportation, beaming objects across the cosmos. Perhaps most astonishing of all evidence is now emerging. The entanglement is widespread throughout the universe, hinting at a level of cosmic connectedness of truly new age proportions. The nature of this connectedness is far from intuitive, defying the usual bounds of space, time, and common sense. It can only be fully understood through the rules of quantum theory, and in particular, a series of discoveries that began with an idea suggested by French aristocrat in 1924. In his doctoral thesis, Prince Louis de Broglie pointed out that recent experiments had revealed that light, usually regarded as a wave, sometimes behaved as if it came in particle like packets, dubbed photons. So perhaps, he argued, particles like electrons might sometimes behave like waves, while properties he estimated using simple arguments. It was a daring prediction, yet just 3 years later it had been confirmed in experiments that showed that supposedly solid electrons could generate the wave-like effect known as interference. Many leading physicists, including Einstein, saw this as a major breakthrough and set about trying to find out more about these strange matter waves. Among them was Erwin Schrödinger, a Austrian theorist who constructed an equation that governed their behavior. This revealed that the waves aren't like ordinary physical waves at all, prompting Schrödinger to give them an altogether more abstract name: wave functions. Schrödinger's discovery was a blow to those who, including Einstein, had hoped quantum theory would give them a clear, common sense of view of reality. Worse was to come with the German theories, where Werner Heisenberg uncovering the famous uncertainty principle, which showed it was